Hi there, and welcome to the AGI Bingo. This is a new channel that I've created in order to map and build building blocks for AI and AGI. I'll be presenting to you the building blocks soon, but to kick off this channel, I would like to present to you the Barz Scale of AGI, which is what we will be talking about today. I'll present to you the idea and the theory behind it, and we'll also walk through each of the phases of the AGI spectrum. So to begin, what is the Barz Scale of AGI? It is a Kardashev-esque type of scale, but for artificial intelligence rather than energy consumption. Most people have a general or even sometimes vague understanding of what AGI actually means. And I'm so amazed how still to this day, the top researchers and prominent figures in the AI space still refer to it as something that has no clear common definition. The Barz scale defines each phase of the spectrum by using a series of increasingly difficult Turing test-inspired checkpoints or milestones, and is meant as a tool to visualize, measure, track, and understand the current and future of AI progress. So what is AGI? AGI is both the term for the entire spectrum of artificial intelligence and also a common term used for a specific phase in it, representing a major shift in technological versatility and capability. This way of definition serves both to unify people's understandings of the evolving nature of AI, offering a mutually agreeable terminology while still making sense to the people in the current zeitgeist. So when speaking with someone about AGI, you could understand if you're talking about a certain phase in the evolution or about the larger spectrum. One funny thing from all of this, it seems that you need to be an AGI to properly understand what is AGI, since it could depend on the context. But luckily, we can create tools to help us out. The main two axes of the Barz scale are versatility and capability. Together, they approximate the measure for intelligence. In the future, I would like to add more dimensions, such as embodiment, accessibility, alignment, morality, cost of operation, and others. But these two will remain the core measures of the scale. So now that we covered the overview, let's dive into each of the phases, starting with the first one. Even though the site is still a work in progress, you can visit it, link in the description. Okay, for the first phase, we have zero AI, or no AI. The threshold test for this phase is that it can be written in pseudocode and implemented in a coding language using logical programming procedures, such as OR, source, functions, and everything that we are used to from coding languages. A few examples from this phase is the classic Hello World program, the much more advanced A-star algorithm for navigation, which is used in all of our GPSs, and at the highest capability level, the entire internet, meaning that everything that runs the internet was written by a human in code that can be written, understandable, and executed by a classic computer. Please note that I haven't added in the axes in the website yet, but as I've shown before, the vertical axis here is capability, and the horizontal axis here is versatility, going from not versatile to super versatile. All of the program written in this phase are completely hand-tailored software, and this age of humanity is what I call the age of tailors. And now for the next phase, artificial narrow intelligence. The threshold test is that it cannot be written in functional pseudocode and is implemented by learning, training, and running. It is characterized by a vertical or narrow domain experience and usually achieves success in one domain. Some examples include MNIST, which recognizes numbers, ImageNet or AlexNet, which recognizes images. After that, we got YOLO, which does insane real-time image labeling. And at the very top, we have things like AlphaZero and protein folding, which are very, very capable, very narrow, one use case programs. Now, on the verge between narrow intelligence and the next one, which is wide intelligence, we have something like the Tesla Autopilot, which still operates in one domain, but can take a wider range of actions. Next up, we have artificial wide intelligence. What does it mean to be wide intelligence? The threshold test is that it can output and respond dynamically within a wide range of inputs and outputs in one or more domains. This is basically describes ChatGPT phase. At the very bottom, we have GPT by itself. It's not very capable, but it can already get inputs that it was not trained on and give out outputs that it was not trained on. After that, we have something like Copilot, but can only complete text and code. After that, we have ChatGPT. This marks the starting phase of artificial wide intelligence. ChatGPT can get inputs that it was not trained on and provide outputs that it was not trained on while still being coherent and doing what the program is supposed to do. Some more examples, we got the classic Turing test, which people claim that it's already been passed. Above that, we have ChatGPT Plus. You can see that it's more versatile. It has function calling. It can run code. It's much more versatile. The latest model by Anthropic. And some people say that less versatile but more capable is Sora by OpenAI. It still operates in one domain, videos, but it has a very wide range of outputs. Practically any video you can imagine or prompt. More versatile examples from this category, we can use AGIThe, which is a programming assistant. It can read your whole code base. It asks you what you want to do with your project, and it will very efficiently suggest code this that will result in what you wanted it to do. Even more versatile, we have things like LangChain, which is a building block for building even bigger AI systems. We have frameworks like AutoGen and others, which can create swarms of agents like AGIThe or other specialized agents to help you do what you desire. Up next, we have something like Devin. Devin was showcased recently and is an autonomous programmer which you can deploy. A bit lower in the capability, but much more versatile, we have things like Open Interpreter, which you can install on your computer, and pretty much run anything that you can run on your PC, and run pretty much anything that you yourself can run. Less capable yet, but more versatile is something that I'm working on, which is called Advanced Atomic Agents. It basically serves as an upgrade for LangChain, and it will help us build the building blocks for AGI. Video about it will be coming soon. The era of artificial wide intelligence can be described as the age of realization, which we're just phasing out of. And now for the next phase, the phase of AGI. The threshold test for artificial general intelligence is if it can continuously explore its environment, improve itself, and learn untrained skills by itself. And much like the Kardashev scale, I categorize AGI into 3 different types. Type 1 can improve and learn new skills without human help. This is a general purpose solver that can operate generally in one domain. One example that I think we already have is Voyager. Voyager came out, I think, more than a year ago now, and it was able to play Minecraft at an amazing level. The main feature it has was an adaptive skill library, and it had the ability to explore the world by itself, create new skills, and improve upon previous skills learned. I think this is the strongest example for artificial general intelligence that we've seen. It's super versatile, even though it's in one domain. Still not very capable because it's still only in a virtual Minecraft game. But you can imagine how you can take this concept of a skill library and apply it to the real world. I think this is our current phase at the moment, and everything that we'll be discussing forward is a projection or a prediction of the future. Artificial general intelligence type 2 can be described and measured by if it can learn and act in new domains with minimal human help. I don't have an example for this yet, but you can imagine that the Voyager system starts working in new domains, not only the Minecraft game. Type 3's test for artificial general intelligence is if it can run independently, be self-managing, and continuously run itself. It is self-reflective, self-improving, figures out everything without human involvement, and it can do generally or virtually anything that you ask of it. The era for AGI can be described as the age of wishes, which we're just about to enter. In this era, we can expect things like AI employees and, at the highest level of capability, things like Jarvis and other super powerful AI assistants. Okay, so what comes after AGI? Well, a couple of things. Let's look at the next one. Artificial human intelligence. The threshold test for artificial human intelligence is that it can operate in reality outside the virtual realm. It can also be split into 3 types. Type 1 already has persistent collaboration with other actors in reality over a long term. Type 2 can operate any tool, can create novel tools, fundamental new knowledge, and act upon it. Type 3 artificial human intelligence reaches human parity, and it can do anything that a human can do. Think about how if in artificial wide intelligence or in artificial general intelligence we had agents, well, now we have full-fledged actors that play a role in the real world. It can act without asking, just like any human. It can act long-term. It can create things only humans can make, and it is self-improving. I think the best way I can describe the differences between artificial general intelligence and artificial human intelligence is the case of the Spotify company. Imagine this: you want to create Spotify. Well, you can go to an AI developer and ask it to generate the app for you. Maybe it can even do cross-platform and integrate all of the apps together, which is not an easy feat, and we haven't seen that yet. Even still, it's not only about making the UI and not even the backend. To create a product like Spotify, you need an entire company. You need legal teams. You need contracts with singers. You need to get agreements with a lot of people in the world to let you operate this scale of a company. And we will probably not see AI companies succeed until they reach a human level of intelligence and be able to make long-term real-world collaboration with people. At the very high-end capability of the artificial human intelligence, we have things like AI Tesla. Imagine that an AI could build the entire Tesla company. Everything from the design to the code, to the factories, to the employment, the production, and the full deployment of all the Tesla facilities and products. Artificial human intelligence era can be defined as the age of choice. A lot of things will be possible, and we need to start making the right choices about what we do. So what comes after that? All of this is still in the realm of what humanly is possible. Humans have already shown they can build these things. So what's higher than artificial human intelligence? That's where artificial superintelligence comes in. The type 1 test for artificial superintelligence is that it can solve any task better than the best human. Type 2 ASI is reached when an AI can be better than all humans combined and solve the unsolvable and solve things that the entire human collective could not have solved already. Type 3 ASI is capable of finding and reaching the broad optimum for all scenarios, meaning that it can look at any situation in the world and apply an approach like AlphaZero to it, where it can automatically find the best outcomes for any situation much better than any humans could have ever imagined. When we have artificial superintelligence, we will have an AI with superhuman abilities across all domains, and we'll start the age of dreams. Beyond that, there is one last category, which is reserved for artificial final intelligence, or AGI. This phase is not so easy to imagine, since a lot of things we can imagine could be already inside artificial superintelligence. But what describes the artificial final intelligence is that it can do the unimaginable. In this phase, the AI has an ever-increasing intelligence, one could say omnipotence, and it will bring us as humans to the age of miracles. Please note that the actual spectrum is continuous according to each of the tests that the AI passes. Some final thoughts I would like to add are that we will be able to find AI programs that write other programs in other phases. For example, ChatGPT can already create programs in the lower left section of the spectrum, but still is not very capable of creating artificial narrow intelligence. At this current time, if you ask ChatGPT to create AlphaZero from scratch, it will probably not give you a very working and good solution. But soon we will see AGIs that can create artificial narrow intelligence and will be able to do that. And beyond that, artificial human intelligence will be able to create AGI for any case. And of course, artificial superintelligence will be able to create an artificial human intelligence for any case. So remember that there is still value in each of the phases. Modern progress still needs to be made on each one of these phases, from the no AI to the narrow AI to the wide to the general and so on. This website is currently under development, but I hope that soon it will be much more interactive and that you will be able to double click and add new projects by yourself and even drag projects around to determine where you think they actually are. We will calculate the global average to get the best representation of the current map of AI. Please remember that this is just the foundation of the scale, and we'll have until January 1st, 2025 to bring forth improvements to the threshold tests and hone in on a polished, well-defined and clear spectrum which covers all cases. Furthermore, if more people seem interested and find this useful, I hope to make this more than just a theoretical scale, but as a public tool, and let everybody drag, adjust, and add new data points to it. If we average everything out, we'll get a better global representation of each point relative to the other points. See them change as time progresses, filter by open source availability and other dimensions, star and save your favorite projects, and also explore and find new ones, and always stay on top of the bleeding edge of AI development. One more thing I would like to mention This is a timeline that represents each of the phases and their duration. Starting on the left, we have the entire human history before computer programming. Then we entered the age of tailors, where for every program out there, somebody had to handcraft a tailored solution and had to implement it by hand. We started creating neural networks, created narrow artificial intelligence to solve things that we cannot program ourselves. Then we entered the age of realization. In the past few years, we evolved to artificial wide intelligence, where we have things like ChatGPT, which can help us in a much more versatile way. And we're just about to enter the age of wishes, where we have artificial general intelligence to do most of the things that we want. After that, we will soon enter the age of choice, where we have human level intelligence at our fingertips and we have to choose what we want to do with our life. As we enter the age of dreams, we will have artificial superintelligence that can radically improve itself and work its way towards artificial final intelligence. This timeline is supposed to show you that each of the phases get shorter and shorter until we reach the singularity. And from the singularity, it will start to self-improve and create the artificial final intelligence, which will accompany us for the rest of our futures. So as the first Barz Scale timeline update for March or April of 2024, I'll be doing this every week or two, and also will add your suggestions to the board. I will be doing that until the website will be able to handle adding new data points automatically. I really hope that all of this will become highly more interactive and better refined as more people become interested. For now, that's the Barz Scale. I hope you enjoyed. To finish off this episode, I will be making a wish segment. Basically, this is where I can explain some of the ideas that I have, where I'm not sure I'll have the time or the expertise to develop myself. And so hopefully I will be able to get some of you guys to make these happen faster. I wish that I had a dynamic web UI to insert multi-axis data points or objects. For example, one axis for benefit and one axis for difficulty. Clicking anywhere on the plot will create a new project or object inside of this scale. I will be able to drag the points around to change their internal levels of difficulty or benefit, and also be able to enter inside of a node to add new dimensions, edit current values and add new ones. And below the plot, there should be a filtered list showcase of all of the projects or objects that can be filtered by the axes, or maybe even searched. I will be able to create new projects very easily, and for each one of them to create a GitHub repository, a website to showcase, a business plan deck, and many other things. Oh, and also that the current Barz Scale site will be better. If you want to see more cool projects, please remember to subscribe and comment. I have a lot more coming. If you want a sneak peek, you can look in the README for the show on GitHub. All the links in the description. Thanks a lot for watching and all the best.